I'm going to be replacing the tie rod ends, that's to say the outer tie rods on this Ford. In this case, the left-hand one has gone quite bad. Now you can see here the movement in the wheel as I rock it side to side. I did a separate video on checking the condition of both outer and inner tie rods, so I won't elaborate on that, although I will show you the failed rod. And obviously the first thing you'll do is have the car lifted up all safely and take the wheel off. Okay, here you can see what we'll be replacing. In this case, the ball joint boot has torn and failed completely, leading to junk getting in the ball joint and wearing it out. You can see here the amount of movement in it. It shouldn't be like this. It should be pretty much rock solid. So first, to take out the old one, I'm going to discuss what you'd do to avoid an alignment if you want to try that. I'll talk more about that later, but it's a good idea anyway to get at this stage a measurement of the existing distance between a fixed point on the inner rod and the center of the ball joint on the outer rod. This is basically a measurement of your car's front toe, and we want to put it back as close as possible. So try to measure this accurately and write down the number so you don't forget it. And next we need to undo the locking nut, which is what holds the outer tie rod in place on the rod. Now these can be seized up a little if they haven't been worked in a long time, but often all you need is an adjustable spanner and they'll come loose like this. On the other hand, if they're tight, you'll need something more serious. The nut on this Ford is 24 millimeters, which I think is pretty typical. But that's quite a big spanner for a DIYer, so you may not have one. My solution was to get this square drive attachment tool, which is called a crowfoot spanner. It's basically a 24 millimeter open-ended spanner that has a 1/2 inch drive to which you attach a breaker bar or ratchet or whatever. So that makes it cheap and convenient and versatile. And if you're going to have to be levering on the tie rod a bit, then you should hold it somehow. Here I'm using a pair of vise-grips, and I'll hold them against a block of wood, which will take the torque as I turn the breaker bar. There's also flats on the tie rod end adjacent to the lock nut, and sometimes they're sort of in the middle of the tie rod. But that's just, in my case, it was a little bit more awkward to do that, and using the vise-grips was more convenient. So once that's held rigid, you can get your spanner or whatever, see how my 1/2 inch breaker bar works with this crowfoot attachment, and put some weight on it, and the lock nut will come loose. Now, once it's free, you don't want to undo it. All we needed to do was loosen it. On the contrary, you want to do it back up by hand against the tie rod, and not tight, but you just want it to be positioned next to it. This will work in conjunction with the other techniques to hopefully again avoid needing an alignment, if it's going to be possible at all. Now moving on, the next stage is to undo the nut on the ball joint stud. For this you need a 15 millimeter socket. Put your breaker bar on it and break it free. If you have both wheels off the ground, this may turn the steering while you're trying to do this, in which case you might need to hold the steering wheel still somehow while you crank on it. Now, the nut will come off at this point, but the ball joint stud is still wedged into the knuckle, and they're usually stuck in there pretty tight. So the usual recommendation is to put the nut back on the bottom of the stud, and you're going to have to smack it with a hammer to shock it free. So by using the nut, you're giving the hammer a bigger surface to hit, and so you won't damage the threads on the stud in case this is a tie rod that you wanted to reuse. Even if you're not reusing it, it's just best practice. So you give it a few whacks and it should pop loose. And once it's free, you need to get the nut off again, and you may find that this is now a little tricky as the whole stud and the ball will rotate as you turn the nut. So to deal with this, these particular studs on this Ford have a 5 millimeter hex socket put into the bottom of them. So all you need is a 5mm hex key inserted in there, and then you can turn the nut with the spanner. And finally you'll have it all free, and the tie rod can come out of the knuckle. Next step is to take the tie rod off. Again, if you're trying to maintain alignment, pay close attention here. You don't want to move the lock nut, and you also don't want to turn the inner tie rod. So hold that still with one hand and start undoing the outer rod. And you want to count the number of turns it takes to get it off, and make a note of that count once it's done, alongside the measurement that you took before.
19, 20, 21, 22, 23.
Now here's my old piece. You can see how ruined it is. This is all loose and floppy. Should be way stiffer than this. And you can see the ball joint itself inside. So what's happened here is the boot has been damaged at some point, and all the grease that should be inside the boot has vanished, and grit has gotten into the joint, and it's slowly just worn itself out. And I'm lazy and I let this go way too long. Now for comparison, here's the new tie rod end. This is from Moog, which is an American aftermarket parts manufacturer. So it's not a Ford part, which might have implications for alignment, which I'll talk about later. But notice how much stiffer the ball joint is, and it's not shown here, but the tie rod should come with a new nut for the stud. You shouldn't be reusing the locking nut. Now, before you put it back on, check that it's compatible, but also the same length as the old one. It's going to have to be the same length for us to maintain accurate alignment. And in this case, they look pretty much the same, but as you'll see soon, they're actually a little bit off. So you can start winding it back on. Again, hold the inner tie rod solid so it doesn't turn. And now you count the number of turns again. The idea being that you would do it up the same number of turns as the other one took to get off. So that would then mean that the position on the thread is identical.
11, 12, 13.
And as you complete the final turn, it should be coming up against the lock nut, which you didn't move. And then this would verify the thread position. However, in my case, you see it's out, and I had to undo the lock nut a further half turn or so in order to allow the new rod to come around so that the stud was pointing in the right direction. So this is now an indication that it's not close enough to the old Ford piece to maintain alignment properly. So we'll be needing to get an alignment. Anyway, that's the best that we can do. So the stud can be inserted back into the knuckle, and you can do up the stud nut. Again, you would use the newly supplied nut. If you're reusing the old nut for any reason, you would want to use some thread locker like Loctite on it, because the modern nylock and other locking nut designs shouldn't really be used more than once. Now, older cars may have castle nuts with cotter pins instead of these locking nuts, but that's not what's on this thing. Now, once you get to a certain point, you'll find that the stud and ball will again start turning with the nut. So again, you will need to use the hex key to hold it and turn the nut on with the spanner. And what you want to do is do the nut up as shown until you can turn it with the spanner without having to hold the hex key. It'll get to that point as the stud is pulled into the knuckle and starts to hold or jam against it. And then you want to stop at that point and get out your torque wrench, because it's important to get the torque correct. The reason for that is you're pulling a tapered stud into a knuckle, and the torque spec is just so for that. Too loose, and there's the risk of coming apart, of course, and too tight, you could crack or split the knuckle. So for this job, you really do want a torque limiting driver of some sort. And on this Ford, the tightening spec is 40 Newton meters. So I set that into this click style torque wrench, which I did a review on recently, by the way, if you're interested. And put the 15mm socket back into action and go ahead and tighten it down. Now the final step is tightening up the lock nut. You could just give this a snug up with your spanner or bar, but in my case, since I have the torque wrench handy, why not use it? The spec for this is about 45 Newton meters, by the way, so about 10% more than what the stud nut wanted. And here you can see another use for the crowfoot spanner attachment. Turns your torque wrench into an open-ended spanner, which is quite neat. And you can see I'm holding the tie rod with an adjustable spanner this time, which is sort of locking itself against something on the suspension while I tighten the nut up. And lastly, you can check the toe measurement and see if it's the same as the measurement you took at the beginning. Now mine looks similar, but as we're about to find out, it's actually quite badly out. So I took my car to get a full alignment, and here are the results. Just out of interest, these are the front wheels, this is the total toe, and then down here are the partial toe. You can see after it should be 0, both left and right. And in my case, it was measuring -7 on the one side and +3 on the other, which is really quite bad. These measurements are basically in millimeters, measurements as taken at the outer edges of the wheel, at the tire. Despite all my efforts, this is how bad it ended up being. So what I'll say in conclusion is, if you want to maintain alignment, you need to do all 3 checks that I showed you in this video, except you would also really need replacement parts identical to what's on the car previously. That's to say genuine OEM, if original parts, because the aftermarket parts, while they can be perfectly acceptable quality, they just aren't made to be precisely the same geometry. So one, if you can take measurements that come out the same once finished, and 2, if you can count thread turns that again are the same putting on as off, and 3, if you are using identical replacement parts, and all 3 of those are true, then you could possibly avoid an alignment. Otherwise, get your car to the wheel shop, because you will be wearing your tires badly. Right, that's about it. Hope this was helpful. Don't forget to put your wheels back on and have fun.